Good morning, good afternoon, and good evening, everybody, and thank you for joining us today. And to this third session, focus on the service strategy. I am Sara Bonito, a researcher of at the Italian National Institute for Astrophysics at the Observatory of Palermo. I want to thank all the organizers of this session, Rachel, Will, Federica, Angelica, Dragana, Maribel, and Ilaria, and the SCOC and OPSIM experts will help us today during the discussion, Peter, Knut, Jay, but I see there are other experts of SCOC and OPSIM today joining us. So thank you for attending this session. Next slide, please. Thank you. This is a friendly reminders. We agree to abide by the code of conduct, and all the Rubin ls.st science platform, science collaborations adhere to the principles of kindness, trust, respect, diversity, and inclusion. So it won't be tolerated any discriminatory behavior, and please use the instructions in the code of conduct if you witness any form of aggression. Next slide, please. All the sessions, the whole session will be recorded today. So if you do not wish to be recorded, you are welcome to keep your camera off. You can give Slack questions a thumbs up, so you will help us prioritize them. And if you want, you can show your appreciation after the talks using the Slack clap emoji or here on Zoom. Next slide, please. Some information. Today, Rachel will be the note takers, but anyone can edit the live document. You can find this link. We will circulate this link here in the chat and also in the Slack channel. And everybody is welcome to add to these live notes questions, suggestions, and open issues feedbacks for the SCOC in particular. And Angelica and Dragana will be the moderators of the Slack channel, which is the preferred channel for questions. But you can also use the Zoom chat, but you can also raise your hand in Zoom here to join the discussion at any moment. Ilaria will moderate and will keep the time for the flash talks. You can find all the slides in this slide deck, and everybody is welcome to continue to contributing slides, adding feedback, open issues, questions to be prepared before the next SCOC meeting in November this year. Next slide, please. Thank you. The organizers of this session started the work in 2020 before the PCW of last year. In particular, among the members of the task forces of transient variable stars and stars Milky Way local volume task forces focus on the survey strategy optimization. You can find the members here. And in next slide, please. Okay, you can see that starting during the hackathon the week before last PCW in 2020, we contributed with several metrics for many science collaborations listed here. And in the next slide, you can see that several science collaborations have formed working groups and task forces to work on the OPSIMs. And all the science collaborations are ready to work in collaboration with the MAF team and the SCOC to integrate the work done for the survey cadence optimization. And the next slide, please. Okay, I want to thank you all the contributors to this session. You can see here a list of some PIs and QIs of Cadence Notes contributed to this session. And this is almost the 80% of all the submitted Cadence Notes. And in the next slide, there should be the session agenda. Yes, after this brief introduction, Federica Bianco will give an overview of the work done by all the science collaborations. Then there will be 2 minutes flash talks by PIs or co-Is of the Cadence Note contributed to this session, grouped by topics. And then we will have the open discussion session. And in the next slide, please. These are the topics and the names of the speaker of the flash talks. And in the next slide. Okay, Federica, you can start with your overview of the science collaboration work done. Thank you.
All right, thank you. I want to pick this up from exactly what you have said a second ago. So let me just point out there have been 3 phases of community input into the survey strategy for Rubin. This work has been going on for a very long time. The first phase is the one that culminated in the COSEP. And in fact, if you think about it, there have been contributions earlier on, particularly in the deep drilling field selection. But at least when we wrote the opening paper of the APJS focus issue, we identified these as the 3 core phases. So this work has been going on for a very long time, since 2015. 2017 is when we published the COSEP, and 2018 is when we submitted the white papers, and now last year we submitted the Cadence Notes. And the thing that I want to point out is on this slide, on this table, which is taken from the opening paper of the APJ as focus issue, is the number of authors that are in each one of these elements of the survey input, which you see here under the response tab. There were over 100 authors of the COSEP. There were over 416 people that contributed to the white papers and 218 to the Cadence Note. So a really large number of people have participated in this. Next slide, please. I'm going to focus on the Cadence Note and then go backwards from there. This is the breakdown of the Cadence Note, of the Cadence Notes by science collaborations. And for the Cadence Notes, typically it's fairly clear which science collaboration is involved in the submission. There were 39 submitted Cadence Notes, and a lot of science collaborations have contributed more than one. 2 science collaborations have provided consensus views, however. So the reason why you see the desk and the sort of system science collaborations, particularly being very small slices here, and probably the galaxies too, although I did not explicitly talk to them about their strategy, is because they provided a single note with a consensus view about what the survey strategy should look like for the science collaborations. However, many of the other ones, next slide, and kind of in rapid succession, the following slides have produced several documents. TVS has produced 14, and if you count the ones in which they've collaborated with other science collaboration, next slide, there's another few, next slide. The AGN science collaboration has produced a large number of notes in this round as well, including one collaborative one, next slide. And the seismic UA and local volume science collaboration as well. So all the science collaborations have contributed at one point or another into the discussion. Next slide. The white paper, much of the same. A lot of the science collaborations have provided more than one point of input, particularly TVS, again, with a large number of Cadence Notes. I'll address that in a little bit. And so this graphic doesn't really render in the Google Slides because it's not interactive. But if you click on the link below and you go on the right, you see the co-author network for all of the papers that have been submitted in the white paper run. That was 46 papers, and most of them have a large number of authors that have contributed to multiple papers from different science collaborations. So it's really been a very collaborative and extended work for all of the groups. Next slide. And lastly, for completeness, on the next slide, I'm going to show just the COSEP chapters. I don't have a graphic to support that, but the COSEP breakdown of chapters, just to give you a sense of what was being submitted, and roughly the chapters follow the science collaborations that you might you might obviously connect to them the solar system, the stars Milky volume, variable objects, which was essentially a collaboration between stars Milky local volume and TVS, transients for TVS, etc., etc. So I think I made the point, next slide, that really all of the science collaborations have worked very hard in all of the phases of the Cadence survey design. There have been contributions from members of each science collaboration at almost any of the steps. And I want to emphasize that all of the people that have put a lot of hard work on this and created maths, created concepts, and then turned those concepts into math have largely done it on a volunteer basis. And it's been lengthy, hard, and extensive work. There have been various types of organizations inside of the science collaborations that supported this work. And Sarah already mentioned it, task forces, for example, in TVS, in the Stars Milky Way local volume. I think it's a working group for the galaxies and for the desk science collaborations. And there have been many topical meetings on the maths organized by the science collaborations, by individual science collaborations, and of joint science collaborations. And obviously here I'm more familiar with the TVS ones because I went to those meetings. So this is surely not an exhaustive set of the meetings that have been devolved to this topic over the years. Next slide. However, and this point was made during the survey strategy session yesterday, and I think it's an undoubtable fact that the metrics from two science collaborations in particular, the desk and the solar system science collaborations, have been integrated into the SCOC evaluation framework in larger number and more successfully. And this is very concerning. And so I want to spend a couple of minutes thinking about it and thinking about how we can mitigate this. So next slide, please. The maths, then so there's a lot of maths going around that have been written by all of the other science collaborations. And I have a suggestion, a very explicit suggestion, that is that all of the science collaborations compile a list of the maths that they, from their perspective, they think that they have created and delivered. And ideally that this list would describe what the science collaboration members think was delivered in terms of, was it a complete math? Was it a math that needed support from the SCOC to be completely integrated in the framework? Was it just a concept of a math that was never actually coded up? Because there are so many maths that are going around and there is so much work that has been done by people from all the science collaborations that essentially is not being leveraged yet by the SCOC because we haven't been able to integrate those maths fully. Some examples that I want to mention in reference to the discussion yesterday, for example, the desk maths include transient and static science. And for the transient science, there are desk-specific supernovae, kilonovae, and superluminous supernovae math metrics that have been integrated. But metrics about kilonovae and supernovae are also produced by other science collaborations. I remember one about supernova precursors by the Stars Milky Way local volume, and certainly TVS as well has produced those. And so we need to integrate those because they might have different perspective about what is a good survey for those science cases. And then there's a lot of other science cases. So next slide, and I will go quickly over the next few slides. Just as a point about the history of this. So I think part of the reason why the desk and solar system maths have been integrated more effectively might be that they started adopting the math framework earlier on. So they had more points of iteration with the OPSIM team to refine their metrics and get them to the point where they can be used. So early on, the science collaborations the other science collaborations, really all of the science collaborations had a number of struggles, but they've been solved over time. So now we have essentially solved the problems about installation and access to the software. We have a number of platforms where we can run the maths and access the OPSIMs. We have ways of sharing knowledge. We're sharing that within the science collaborations, and I want to suggest ways in which we can get more connected with the math team to share knowledge and expertise better. I want to give a shout out to the AGN science collaborations that have done a huge amount of work that really was productive to get us to get all the other science collaborations to write maps when they enabled the SciServe to run maths on, and now we also have access to NOIR facilities. And again, there's this metric limbo, I called it, where we have a lot of maths that we think are complete, but they're not integrated, and they're probably not complete from the perspective of the OpSim team, and we need to get them to really be integratable and complete. So next slide, I have 3 suggestions, and with that, I'm done. So I think the priority now should be on the integration of existing metrics from the science collaborations that are not in the set of metrics that the SCOC uses right now. I think that should be the priority of the OpSim team in terms of support, and it should be the priority of the science collaboration in terms of trying to make sure that the people that have already done a lot of work can see their work being leveraged. Next. I want to emphasize that the SCOC and the OpSim team should not expect that all science collaboration can get to a consensus metric. I think TVS has been quite explicit in saying that we will not provide a single metric for our science. That our science, the breadth of our science is such that some survey strategies that are favorable for some of our science collaboration will be unfavorable for the rest. And we think that the aggregation at that level is a responsibility of the SCOC and not of the science collaboration itself. And I want to point out that there is a reason why the pillar about transient science of Rubin is called exploring the transient and variable sky, right? Because there's a lot of things that we don't know, which makes it harder to create very interpretable metrics sometimes, which brings me to my next point with the next slide, which is that not really all science can be in simulated things that we inject in the OpSims and then extract. So these are obviously the metrics that are easier to integrate in the SCOC inputted in the framework, the ones that rely on number of objects or similar, simply interpretable schemes. But I did talk to some members of the SCOC. I did talk to Renee from the SCOC just a few minutes ago. And even if the concept that you have for your science doesn't trivially lead to a metric in this sense, we need to find a way in which that can be taken as input. So include these metrics, include these metrics in the list of metrics of the science collaborations, and describe the points that you want to make and describe why they can be made in terms of a simple number of recovered objects or something like that. And then the last slide, I made this point. I think we need to provide a list of all the science collaboration metrics and share with the SCOC so that we can see which ones are integrated, which ones are not, and how we get them integrated. And finally, we can think about how to actually do this. So next slide, and the one after that, which will be my last one. Perhaps we can have monthly meeting with the SCOC and the science collaborations that can alternate the science collaboration that is leading the discussion. That's one of the things that we talked about earlier with Renee. We need to obviously see if the rest of the SCOC and the science collaborations are amenable to this. And next, I think I'm done, actually. I think that was my last slide.
Thank you, Federica, for this interesting presentation. Now let's start with the flash talks to illustrate the Cadence Notes. And this talk have been organized by topic or by science collaboration. Here there is the list. The first is time domain science in the galactic plane and Magellanic clouds, told by Rachel.
Sorry, Ilaria, before
Yes.
leaving room for Rachel, Dragana and Angelica are monitoring the Slack channel and the chat here. We know there are some questions or comments, but please wait for the discussion part after this flash talk for the general discussion, if it's fine with you. Thank you.
Yes. Thank you, Sarah. Rachel?
Thank you. Could we go to the next slide, please?
Yes.
Thank you. So the diversity of stellar science. Oops, could you go back one?
Back?
Yeah.
Oh, do you see?
Thank you. Yes,
Okay.
That's great. Thank you. I wanted to capture the diversity of stellar science, which is obviously what makes it so fascinating. But it also presents a challenge in trying to find a survey strategy that will serve so many different goals. This table represents the specific contributions to just this session, which I'm trying to summarize here. But I want to stress that there are many, many more white papers and Cadence Notes from TVS and STARS Milky Way, but also from many other science collaborations, which highlighted the range of the very important science drivers. So they range from studying young stars to star-forming regions, through every type of stellar variability to transient events such as microlensing. And many of these authors have now contributed metrics which describe their science in detail. Next slide, please. But when we reviewed the SCOC's report last year, it was clear that there was a need for a more general figure of merit that could be used as a proxy, encompassing the most significant factors impacting all of these science cases, if not capturing the full detail. So without taking a broader view, the survey optimization could become impossibly complex. So we've attempted to produce such a figure of merit by concentrating on the most impactful observational parameters for each survey strategy. And those are the survey footprint and the time cadence. The 2018 white papers identified the most important regions for stellar science in the galactic bulge, the plane, Magellanic clouds, and numerous star-forming regions and clusters. And we've combined these to produce a HealPix map, which you can see here, which shows the priority of each pixel pointing for that particular science. We then identified 4 categories of variability, both transient and periodic, distinguished by the timescale of variability, which then dictates the required interval of observations. And our proposed figure of merit combines these observable parameters. So we're at the stage of having drafted code for this work, and we're working to resolve some outstanding issues, particularly the representation of color measurements. So we look forward to working with the math team on that in the future. Thank you.
Thank you, Rachel, to be on time. Next topic is AGN and Blaser by Angelica. Please.
Thank you, Ilaria. AGN and TVS collaborations designed 4 types of matrix testing ls.st strategies for mapping AGN cardinalities, spectral energy distributions, and light curve properties to time and spatial scales defined by processes in uncreating supermassive black hole and cosmic expansion. Blaser relativistic beam jet emission imprints the variability on shortest time scales, down to days or even less. According to saturation metric, light curve sampling at color metric, saturation will affect 3 to 6% of Blaser observations. OPSIMs with 15 seconds exposure and DDFs are acceptable for Blaser research, although DDFs cover a limited region of the sky. The continuum and line emission fluxes of AGN define time scales of tens to hundreds of days, while expected binary Keplerian signals are several years to centuries. Their unified metrics indicates that denser rolling cadences, such as in R-band and DDF, are preferable, and machine learning can assist with cadences containing at least 100 observations per 10 years. At the largest time scale, around cosmic noon, quasar photoseas rely primarily on detecting spectral features on the broadband spectral energy distributions, and we find that in terms of depth, no opsim is generally detrimental for detecting SED features, but as deep U-band coverage as possible will be useful. We find one opsim, baseline same filter, is detrimental, however, when considering the effects of variability. The second metric estimates the number of quasars detected in I-band, and we show there is a modest preference for strategies with larger WFD footprints. Thank you.
Thank you, Angelica. Next speaker is Igor about supernovae, kilonovae, and time disruption events.
Thank you. Can we please go to the next slide? I will try to summarize here the results and the suggestions put forward by some subgroups of the TVS collaboration, in particular for supernovae, kilonova, and TDEs, which are transients that are extragalactic, but from quite different type of origin. Supernovae from stellar explosion, kilonovae from the merger of neutron stars, and TDEs happening when a star is disrupted by the proximity to a supermassive black hole. So several metrics were developed in order to be able to inject and then recover light curves of transients in the simulated cadences so that we could establish their effectiveness in detection and characterization of the light curve for the science cases that we preferred. It was found in particular that for TDEs and supernovae, more blue filter coverage will be preferred. And in particular, at least for supernovae, deeper U-band imaging is recommended. On the other hand, for kilonovae, it would be better to have more red filter coverage instead of blue filter coverage. And in particular, I would like to stress that eventually individual 30-second exposures would be much preferred to pairs of 15-second snaps so that we could explore a larger volume. For the kilonova and supernova science cases, we agreed that same-night triplets can be beneficial, for example, in the press-to-color strategy, so that transient can be found and characterized earlier on. Rolling cadences could be preferred to the baseline strategy. And in particular, we would really like the cadence, the frequency of the observations to be kept as is or increased, but please do not decrease it when making decisions. Some outstanding issues that we identified is indeed the implementation of rolling cadences, and that we would like to understand more and more how the algorithm that were so successfully developed by Lynn and Peter can be further improved. And of course, there will be more to talk and discuss about synergies, in particular with UV space-based observatories, especially for the TDE science case. Thank you.
Thank you, Igor. Next speaker is Jeff, told about Milky Way and local volume.
Yeah, thank you. It's difficult, I guess, to represent the broad range of sort of science interests represented within the STARS Milky Way and local volume science collaboration. So we can't, I guess, very easily sort of wrap things up into a single sort of recommendation, but rather I'll highlight some of the recommendations from this handful of Cadence notes that were submitted. So if you go to the next slide. So these Cadence notes range from looking for dwarf galaxies out to distances as large as 6 megaparsecs, to looking for dwarf galaxies and star clusters around the Magellanic Clouds, and to some of the brightest stars in the sky and stars within the bulge and the disk of the Milky Way, and even the solar neighborhood. So you can imagine the needs for these different science projects vary widely, but but sort of to summarize, the metrics that we developed to assess detection of dwarf galaxies, for example, in the local volume and around the Magellanic Clouds. In both cases, wider area benefits these, and if possible, a deeper wide, fast, deep footprint. And of course, in the case of the Magellanic Clouds, that includes extending to the South Galactic Cap. I would also note that both of these, the first and the last on this list here, both benefit from deeper G-band observations. And that's even, we found significant improvements even just by going to a single 30-second snap in G rather than two 15-second snaps. Then going to some of the nearby stars, more nearby stars. There is one rather unexplored regime in the simulations, which is the very bright objects and how to avoid saturation of those objects. This, of course, prefers some very short exposures, and that there's work to be done on that. And then for the galactic bulge, there are a number of metrics that were developed, actually. Many of them benefit strongly from U-band coverage to get metallicities of stars in the galactic bulge. And of course, in the plane, we prefer good seeing and large area coverage. And finally, for astrometry of brown dwarfs in the solar neighborhood, again, you need wide coverage. And this is best accomplished in the reddest filters. And we also found for this case that the single 30-second snaps are preferred over the sets of two 15-second exposures. And in particular, for the brown dwarf parallaxes, we want to emphasize that twilight observations are critical for these parallaxes. And there are some concerns then about satellite constellations contaminating those, but that is a critical portion of the brown dwarf astrometry. So there are a variety of metrics that have been developed, and we look forward to working with the SCOC and integrating these into the MAP framework. Thanks.
Thanks, Jeff. Next speaker is Weixiang about data analysis. Please.
All right, good. Thank you. Can you please go to the next slide?
No. Sorry.
Yeah, can you go to the next slide?
The next,
yeah,
there isn't the slide, perhaps. I don't know.
So the first slide.
Oh, okay. This. Yes.
Okay, good. The first slide is led by questionnaires. So what they do is trying to determine the minimum number of visits required to accurately measure the periods of variable stars using long SCARGO. What they did was build a library of synthetic light curves from a cross-matched sample between Gaia and ZBS. And then they reported the relative error in the long SCARGO periods determined from the simulated light curves as the final metric. They determined that with 10 observations, they can reach a 0.1% accuracy with 50% chance, and with 15 to 20 observations, they can reach 1% accuracy with 99.7% chance. The exceptions are the type 2 CVS and mirror variables, where you can see from the plot on the top right. Next slide, please. This is for chromatic extraction. DCR manifests as a filter and SED dependent precision offset along the zenith angle caused by the atmosphere refraction. So for objects with strong emission lines, additional offsets, precision offsets can be induced, and this offset is also redshift dependent for astrogalactic sources. So it's really useful. This information is really useful for classification and photo Z estimation. So to first order, this offset is linear in the tangent of the zenith angle. Our goal is to maximize the amount of DCR information that can be extracted from the survey, which is basically boiled down to minimize the scatter on the slope in the equation on the top left, which is m. So our goal is to minimize sigma m. Our results found that we will like longer U-band exposures, DCR and DM family simulations, which add extra pairs or extra observation at high air mass are also preferred. We have no strong preference on the rolling strategy. Worth noting is that our metric is actually, although the M, which we're trying to measure is SED dependent, but the metric itself is SED independent. The open question that we have is we worry that the DCR information will get lost in the astrometric solution and we will never be able to recover it. Thank you.
Thank you. Next speaker is Xiaolong about anomalies and true novelties.
Thank you. Could you please go to next slide? Okay, so we derived 5 metrics to evaluate the performance of ls.st simulations to discover the unknown phenomena. The phenomena for the phenomena we have never seen before nor predicted from theory. We use a model-independent approach. We evaluate by evaluating the completeness of the survey in a phase space defined by the flux change, color, and weight by depth, footprint, and also proper motions. And if you go to next slide, next slide, you can see the top 5 families for the time domains or the rolling, or the short twilight, wide fast steep at scale 0.999 and rolling cadence. While for the proper motion, the right panel for the proper motion, the feature dist is the best one for the discover the anomalies in the proper motions. Thank you.
Thank you. Now we have the science collaboration topics. The first, static strong lensing science, taught by Timo.
Hi, everyone. Thank you. So the strong lensing science can be split into sort of like transient or dynamic science cases that are mostly time delay measurements to do cosmology. And this we've done as part of the desk observing strategy, white papers and math and stuff like that. So we submitted one cadence note that dealt with static strong lensing. So this note, wanted to maximize the discovery of strong lenses. And to discover strong lenses, we need a wide area. It's much more important than depth.
All the volume that you have.
Believe it or not. And another important thing is to have very good image quality. Okay, so this is very good seeing, particularly on the bluer side. So we have proposed for a couple of years now, starting with the original white papers in 2018, I want to say. We were suggesting to do an early reference image, an early reference survey with high quality imaging in the G-band. So in the Cadence Note, what we did was study the different observing strategies and what would be the image quality that they would have. The best image quality for the best image quality epoch, okay, single depth for each one of the surveys. That is what you can see in the plot in the right. And on the left, you can see the median seeing. So the median seeing is not good enough for us. So you can see that in the blue, and what we call the blue is basically the G band, we have seeings that are twiddling 1 arcsecond, which is not very good to find lenses. However, if we do an early sky survey, we can reach seeings of about 0.7. Different observing strategies are slightly better. So we focused our note on 2 families. The filtered disk family that had a larger area due to our first aim, and then the baseline-like area that are the good seeing family surveys. And we can see that there is minimal impact on other metrics, simple metrics like depth and cadence, if we reward good blue seeing. And this can be basically completely mitigated if we follow a different observing strategy on the first year than on the rest of the survey. Okay, and we propose that we observe good seeing in the blue for the first year only. Thank you.
Thank you. Next speaker is Ben for the Galaxies Science Collaboration.
Hi, everyone. So to dovetail with that, for Galaxies, we need uniform, high quality static data. The second point here is to mitigate scattered light. And this is something that we need to explore the strategies during commissioning. What exactly that looks like, how the initial data looks, because scattered light is incredibly important for the low surface brightness component, which is where Galaxies, where a lot of the information for Galaxies lies. So dovetailing with what the previous speaker said, we do need an excellent seeing in 1 band or 2 bands early in the survey so that we can base the photometry for extragalactic sources off the excellent seeing one. Whether or not that is G band, I think in our discussions it was mostly, we were thinking R band or I band, so that's something to hash out. But we did come up with a figure of merit for the seeing for extragalactic sources, but we do need 1 band to be the detection band. And the second part of that is to have a full depth deep drilling field early in the survey in one of the deep drilling fields, so that we can have an idea of what to expect, whether or not signal to noise improves over with exposure time. And then other things that we talked about were to extend the survey to more northern areas, so we have better overlap with Euclid, because the talk is to have shared pixel analysis of extragalactic sources. So if we want to improve our photometry, better overlap with Euclid would do great. And to have a mini survey on the Virgo cluster, which I think Harry came up with, that would have the highest stellar mass per volume, so payoff. And so for the U-band, we would favor fewer but longer exposures, to optimize for better weather and low air mass, so that we can add the U-band. The U-band is particularly useful for instance, the deep drilling fields, but we do not have to have a high cadence. It just needs to be integral deep field. And so those are the main points that we discussed among the Galaxy group, and these are the ones that we came up with. Brand can back me up as well.
Thank you. Next speaker is John about the time domain extragalactic survey. Please.
Yeah, can you hear me all right?
Yes.
Yeah, okay, thanks. Yeah, so hi, I'm John. I'm just filling in for Chris, who couldn't make it today. So I'll be talking about the time domain extragalactic survey, or TIDES. So this is one of 10 Foremost consortium surveys. Foremost is a spectroscopic instrument going to be installed on the Vista telescope. So naturally, it'll be the ideal facility for following up ls.st. So there'll be a lot of overlap, as you can see in the top right plot. We've got a density map of Foremost field visits and 2 of the ls.st cadence simulations. So naturally, there's a lot of overlap. And TIDES is focused on following up ls.st transients for the next generation of cosmology. So this will be the largest spectroscopic follow-up campaign for ls.st transients, and we'll be able to measure cosmological parameters to an unprecedented degree of precision. Now, we'll be exploiting the fact that wherever foremost points in the sky, there'll be ls.st targets to follow up due to the event data stream from ls.st. So we'll use our allocated 250,000 fiber hours on foremost. And once we get the alerts from ls.st, we can target these fibers in a rapid turnaround of 3 to 4 days onto our targets. So a lot of our conclusions from the Cadence Note align with the desk Cadence Note. So I guess the main takeaway is that a good cadence and survey strategy for desk is also a good strategy for tides. So that's pretty much it. Thank you.
Thank you. Next speaker is Umna on the dark energy, for the dark energy science collaboration. Please.
Thank you. Hi, I'm Hamna. I'm speaking on behalf of Michelle Lochner and Dan Skolnick, who led the desk Cadence Note. And this work has been basically done in the desk observing strategy working group. So just as a bit of a background, desk of course focuses on cosmology, and the current probes that they've been currently focusing on include large-scale structure, weak lensing, supernovae, strong lensing, and kilonovae, and all of these of course depend on photoses. So these are the sort of science goals that we are keeping in mind when we think about the optimization of the observing strategy. So for the desk note, for the Cadence Note, we developed several cosmology-related metrics, including probe-specific and combined probes. So an example is shown in the plot here, where we have a combined metric that incorporates the statistics from some of the probes as well as systematics. And we basically can look at how this combined metric varies with some of the parameters, including, for instance, effective area and the median number of visits per pointing. And that gives us a sense of like, okay, what are the trade-offs and so on. In the Cadence Note specifically for wide, fast, deep, one of the main recommendations was that we want to define the extragalactic part of the footprint using a dust extinction limit, because that is one of the dust is one of the main systematics that we worry about. Another thing to point out here is there's an internal trade-off within desk between cadence and area, and we are working on this, of course, and I guess one main thing is that we don't want to reduce the number of extragalactic visits. So how do you do that while expanding the area and having good cadence? And rolling, of course, is a good solution to this, and that's why we push it for that. For DDFs, we recommended rolling in order to maximize the scientific output, as well as increasing the allotted time. Basically, any additional time for Rubin should be going towards DDF. So this Cadence Note is linked up there. There's an accompanying journal article that basically is much more expansive in terms of the metrics, the different takeaways. So I suggest that you take a look. And of course, if you have any questions, concerns, please reach out. Thank you.
Thank you. The last speaker is Laura Inno for the Solar System Science Collaboration.
Yeah, thank you, Ilaria. Can you go to the next slide, please? Okay, thank you. As Federica mentioned before, in order to answer to the Cadence Note call, the Solar System Science Collaboration choose a unified approach, meaning that we equally considered the impact on near-Earth objects, interstellar objects, trans-Neptunian objects, main belt asteroids, and comets, with the main common science goal of increasing at least of 1 order of magnitude the sample size of known objects for each of these species. Therefore, we evaluated in priority order, as you can see on the slide, the impact on the discovery orbital characterization, then the color measurement, and finally on the rotational light curves. So we computed figures of merit for each of those science cases and for each species. And specifically, we used the notebook prepared by Lynn to compare the relevant metrics obtained with a baseline cadence or within a simulation family. And on the basis of the results, we labeled each simulation as silver if it's preferred, green if it's acceptable, red if it's not acceptable, and blue if we think that it requires further testing during commissioning. The ranking for each simulation is available at the link in the bottom of the slide. But please keep in mind that some scenario might become red when we consider it in combination with others. And the figure in the slide on the right panel is just one example of our evaluation process, and it's about the filter distribution. The figure of merit on the top concerns the number of visits that allow objects to be identified, while the one on the bottom shows the inversion of the like curves. We considered that all simulations that yield a decrease larger than 5% are unsuitable. Therefore, in this case, only the baseline cadence is okay, and that's actually a good compromise between having enough observation in the red bands for detection, given that some solar system objects might be too faint in the blue bands, but also include enough U and G band observation, which are very important, for instance, for the characterization of active objects, so for a different size case. So all the final critical requests from us, the most relevant of which is related to increasing the coverage of the northern ecliptic spar, as well as the open issues, are listed in the slide that prepared for the discussion later if we still have time for discussion. Thank you.
Thanks to all the speakers for the very interesting topics. Now let's start the part relating to the questions and the discussion. Sarah, do you have?
Yes. Thank you, Ilaria, and thank you to all the speakers. I'm conscious of time. With just 5 minutes, 6 minutes left, but I think it is important to have this overview of Cadence Note metrics already done, and maybe now it can be a brief discussion on how we can provide feedbacks to the SCOC to provide the metrics we are working on already or that are in development. I see Meg has raised her hand, so Meg, if you want to step in. I saw in the Slack channel there were some questions, some already were, there are also some replies in the Slack channel. We can continue also the discussion if we will run out of time. So Meg, please.
Sure, just a quick, I think, comment about thinking about how to get metrics in. So wearing my co-chair hat for the Solar System Science Collaboration on, I think one thing to really note is that, you know, we had metrics that were developed by some of our science collaboration members. And that, you know, I think it's figuring out how to get that help. I think Peter and Lynn have really offered a lot of options to be able to get that help. And I think it's figuring out what was useful then for making sure we get the other science collaborations in. But I think it's really important to recognize that there has been a lot of different ways of doing that outreach as the scheduler team has done to try to help with making these metrics. And that, I think, thinking about, you know, that November workshop is a really good timeline to get in those metrics, or, you know, get help on them before that November workshop that's going to happen with the SCOC, I think is going to be really helpful for everyone. And so maybe we can frame it thinking that way of what is it that would be useful for people that have things in notebooks. How do we get them to something that could have a pull request by November, that November workshop? So that November workshop is really productive.
Thank you, Meg. In fact, I would like to also highlight that this slide deck will be available to anyone that want to continue contributing with adding slides with the feedbacks, opinions, and continue the discussion from today on to be prepared for the November SCOC meeting. And Dragana and Angelica, if you can select one brief question that didn't receive a reply on Slack already.
Sarah, there is a last question from Loredana. I don't know whether she wants to say it aloud, but I can read it. So the question is, how does free Wi-Fi deep area is defined? We presented a Cadence note showing the benefit to observe also the inner galactic plane using the Wi-Fi fast deep strategy for GRAI, or at least 2 filters, and they obtained a gain of 70% in the number of new young stars by using the fast deep with respect to the baseline OPSIM. And this is crucial to avoid gaps in the galactic map and characterize the galactic structure. So the question is, does the dust-free map cited in the SCOC report take into account 3D extinction maps? So that's maybe a question for the last couple of minutes. Others, I think, have been answered.
Should I give a quick answer to that, or do you want to move on to other stuff and we could address it maybe more in depth in Slack? Okay.
Yes, Lynn, please.
Okay. So our proposal for the updated baseline is that the dust-free wide fast deep is the area where the dust extinction E B minus V is less than 0.2. It's not a 3D dust map. It's just the total dust extinction through the line of sight of the galaxy. We actually did add a wide fast deep level region in the bulge of the galaxy. It doesn't cover the entire width of the galaxy. Like it doesn't go up and down plus or minus 5 degrees. That's one of those things I think that we can optimize and we can look at. There was sort of a general thought that consolidating areas was a desirable thing. So instead of having a thin stripe of wide fast deep coverage throughout the center of the plane, instead of having having a larger area that covered the bulge and that connected to the rest of the deep dust-free wide fast deep would work better for calibration and also just for like understanding where stuff was on the sky. We do run into time constraints too, so it's a trade, like more area around the bulge versus this thin stripe throughout the rest of the galactic plane. Those are the kinds of things that we can wait and we can look at what the differences are and that come back to the SCOC.
Thank you. Thank you.
Thank you, Lynn. I don't know if we have time for some more quick questions. Slack, if there is one.
There is a lot of this discussion going on Slack related to the selection of the switch from the exposures. So the arguments whether to use like 30-second exposures or 2 times 15 seconds, so by Tony Tyson. And so there's a lot of discussion on it. So I don't know whether we should comment something here on that or we just leave it for Slack.
There is also one here in the chat. A lot of slides. Yes, thank you, Jeff. I wanted also to highlight that, and thank you, Jeff, for suggesting this. In the Slack channel, in the slide deck, you will find a lot of slides divided by part 1 with individual Cadence Note scientific topic that today have been grouped by topics. By the speakers. I want to thank them again for doing such a great job in just 2 minutes. But in the part 2, you can find also questions, opinions, feedback to the SCOC. So you can add your own, or you can just check some of that. This was just an example. You can see it to be done. And yes, thank you for continuing providing material on the work, all the groups and in the task forces in all the science collaboration done for the metrics. And I am aware that this discussion will continue, maybe not today because we are 2 minutes out of time, so sorry for that. But in the Slack channel, but also during the office hours, Peter and Lynn kindly offered to provide again maybe starting from September. And thank you again, Lynn and Peter, for the huge amount of work you've done with the simulation you've done. And all the science collaboration will continue to keep in touch with you to provide the metrics developed or to provide feedback to you. So thank you all. If there are no last minute comments, thank you for attending this session today. And thank you to all the speakers.
Thank you. Bye. Thank you.
Thank you. Bye.
Bye.
Sarah, should we stay for a minute?
We are landed now.
I think it was a very nice session.
Yeah,
Even though a lot of things, to say.
It is a pity that the discussion at the end was just a couple of minutes, and but I think it was good to present the work done also after the session 1 and 2. So now we are aware of what we should provide best or in addition to what we have already provided, as also Federica mentioned during her talk, starting from the white papers in 2018 and with the Cadence Note now. And so more work should be done, but now I think we know the next steps to proceed. And thank you very much to all of you, Angelica, Dragana, all the others, Melissa, for setting this Zoom room for us. And okay, thank you.
Thank you. Thank
So
you.
I just have one question for you, Sarah. Should we maybe copy some of the comments or the discussion from the Slack to this notes, this Google Doc that we are having?
Yeah. Yes,
Would that be
please.
useful or not?
Yeah, because if I understood correctly, so Melissa, please tell me if this is right. The Slack channel is not, at some point will disappear. So we should, okay.
It will disappear or not?
Yes.
I think no.
No, yes, Melissa is.
Ah, yes, okay, sorry.
Yeah, so it is very useful if you can please add the name of the contributor and the question, just grabbing that so we can save this discussion. Also because, as I was saying, these live notes as well as the slide deck will be actually a starting point from today to be prepared for the November SCOC meeting. So we will continue this discussion. And so this material will be very important. I will use this also for tomorrow wrap up for the breakout session. But yeah, it will still be available tomorrow for Slack. But in any case, the live notes will be where we will use all the information.
Sarah, you will put the Google Slides on the website of the conference and
yeah, it is already there.
Okay.
Yeah, I suppose it is the latest version because Federica uploaded some different slides. So I think it is the latest version. I will check this again. In the website there is the slide deck, but there is I suppose there are not the live notes, but I saw you are posted in the Slack channel, which is the right place. Yeah, it is the right place to do that. Thank you very much for your support.